All right, guys, we're going to talk about trig form of complex numbers. So, two things I want to tell you before we get started. First of all, trig form of complex numbers, I don't remember ever coming up in calculus. I'm teaching you this because the state of Kansas told me to. If somebody else can let me know what they're used for, I'd be jazzed to let you know. Okay. The second thing that I want to tell you about with this guy is that it might feel a little bit like, why the heck is this in the vectors unit? Like, what does vectors and trig and complex numbers have to do with each other? Well, there's a few things. So first of all, let's talk about how to plot complex numbers in the complex plane. So our horizontal axis is going to be our real axis for our real numbers. The vertical axis is going to be our imaginary axis for our imaginary numbers. So if we wanted to plot 3 plus 2i, first we would go over 3 on the real axis, and then go up 2, on the imaginary axis. So there's 3 plus 2i. Let's try the other one. So negative 1 plus 3i, so we'll go left 1 and then up 3. There's negative 1 plus 3i. So then negative 2, or minus 2i, go left 2, down 2. There's negative 2 minus 2i. Okay, so to write this in trig form, what we're going to need is an r value right here. Now, the way that we find r, or that radius, we're going to draw a line from the origin out to that point. This guy right here is going to be r. So if we made this little triangle here, we know this is 3 and this is 2. We do the Pythagorean theorem to find r, right? So we'd have the square root of 3 squared plus 2 squared. Hopefully this looks familiar. That's just like magnitude, right? If 3 and 2 were part of vectors, we would find the magnitude the exact same way, at the square root of 13. Then we want to figure out the direction that this number is in. So 2 is my opposite side, 3 is my adjacent. It's tangent that uses opposite and adjacent. So we'll have to take the inverse tangent of opposite over adjacent, so 2 over 3. And when we put that into our calculator, we're going to get 33.7. So to write this number, we've got the square root of 13 for r, cosine of 33.7, plus I, sine of 33.7 degrees. And that right there is trig form of 3 plus 2i. So you can see right here, we find r by taking both of those pieces, squaring them, and add them together. Find theta by taking the inverse tangent of b over a, just like for a vector. It's the same sort of idea. Now, I don't know about you, but this answer looks big and gross, and it feels like it's not simple enough. First of all, it's totally fine. That's exactly what it's supposed to be. But if you saw that, you might be tempted to go and, oh, I'll simplify it. I'll distribute that square root 13 on out. Well, if you take the square root of 13 times the cosine of 33.7, you know what you're going to get? You're going to get about 3. Not quite, because we rounded here, so it's going to be a tiny bit off. And if we take the square root of 13 times the sine of 33.7, we'll get 2. So we end up with exactly that standard form of our complex number before. So if we wanted to figure out from trig form, turn it back into standard form, we'll take that r times the cosine of our direction for our a real part, and r times the sine of the direction for the imaginary part. Okay, so we want to write the complex number in trig form, and I think it is super duper helpful to go ahead and draw a little picture. So we got this. Here is my imaginary axis. This guy is my real axis. And we're going to plot -7 plus 4i. So that means we'll go left 7, up 4. So to figure out what r is going to be, super similar to finding a magnitude, we'll take that -7 and square it, plus 4n squared. Let's see, 49 plus 16 is a square root of 65. Now we need to figure out our direction. So we've got the inverse tangent of b over a, so 4 over -7. And when we pop that into our calculator, we're going to get -29.7 degrees. But -29.7, that would be over in that direction. So what it's telling me right now is that this angle right here is 29.7. So in our system, we need to start here and get to that line. So we'll take 180 minus 29.7. So our direction will be 150.3 degrees. So for that trig form, we've got our r value, which was the square root of 65. And then we've got the cosine of 150.3 degrees plus I sine of 150.3 degrees. All right, let's look at z equals -2i. This one, if we try to do it by hand, it's not difficult, but it's actually a little bit easier by looking at it graphically. So let's see, my vertical axis is my imaginary axis. My horizontal axis is my real axis. So to plot -2i, we're going to go down 2. -2i. There we go. All right, so to figure out what r is, we can absolutely take 2 squared plus -2 squared, 0 squared plus -2 squared and get 2. Or, how long was that length? 2. So we know r is equal to 2. Now, if we tried to find theta, we would have the inverse tangent of -2 over 0. But your calculator is not going to like that since tangent is undefined. Or that value is undefined. They're not going to like it. But because we know the unit circle, we know exactly what direction this is. Straight down is 270 degrees. So we've got our r, we've got our direction. So to write this guy in trig form, we've got r, which was 2, parentheses, cosine of that direction, which was 270. If you told me 3 pi over 2, I'd be fine with that. Anything that's the same thing as 270 degrees, I'm happy with. And then we've got I sine of 270. All right. So to write a complex number that's in trig form into standard form, all we're really going to do is just go ahead and simplify. So first of all, we're looking at the cosine at -pi over 3 and the sine at -pi over 3. Now, -pi over 3 is the same thing as 5 pi over 3. And at 5 pi over 3, the coordinate is 1/2 -square root 3 over 2. So when we go and start simplifying this guy, we're going to keep the 8. But the cosine at negative pi over 3 is 1/2. Plus I times the sine at negative pi over 3 was negative square root 3 over 2. So then we'll take that 8 and distribute it on out. 8 times 1/2 is 4, plus, well, I guess minus, because we got a negative here, right? Minus 8 times negative square root 3 over 2 is negative 4 square root 3. And then we've got that I. Okay. Over here, we want to write this in standard form. So we've got 2 times the cosine of 120 plus I times the sine of 120. So at 120 degrees, our coordinate is negative 1/2 square root 3 over 2. So we'll start simplifying. Z equals 2 times, our cosine at 120 was negative 1/2 plus I times the sine at 120 was square root 3 over 2. So then we'll distribute that 2 on out. 2 times negative 1/2 is negative 1 plus 2 times square root 3 over 2 is square root 3. And then we still got that I. All right. So the next thing we're going to look at is multiplying and dividing complex numbers in trig form, which sounds terrifying, but it isn't at all. All you have to do is use those formulas. So if we're going to multiply two complex numbers in trig form together, we will multiply their R values together and then add the directions. So, for example, down here, we've got these two complex numbers that we want to multiply. So we'll start by multiplying our R values. So we'll take 3 times 2. And 3 times 2 is 6. Good deal. All right. And then we've got cosine of our two directions added together. So pi over 4 plus 3 pi over 4. Well, pi over 4 plus 3 pi over 4 is 4 pi over 4, or just pi. So we have 6 times cosine of pi plus I sine of pi. And we want to keep this in trig form, so we're going to leave it like that. Now, if we want to divide two complex numbers in trig form, we're going to take the R values and divide them, and then subtract our directions. So when we divide these guys, we'll divide our R values. So R sub 1 was 3. R sub 2 was 2. So we have 3 over 2. Times, then we got that cosine. And we need to subtract our angle angle measures. So we'll have pi over 4 minus 3 pi over 4. Plus I sine pi over 4 minus 3 pi over 4. Well, pi over 4 minus 3 pi over 4 is negative 2 pi over 4, which is negative pi over 2. So we're going to end up with 3 over 2 times cosine of negative pi over 2 plus I sine of negative pi over 2. And that is it. All right, I will see you guys later.